paper, scissors homework problem. So this one's a little bit tough to sort of figure out what exactly they're asking. So let's talk through it. So it says, suppose a certain person picks each outcome completely randomly when playing rock, paper, scissors game. So that means that theoretically, okay, a person is going to pick rock, paper, or scissor 1/3 of the time. There's 3 choices or 3 outcomes, rock, paper, or scissors. So just like when we have a die that we're rolling that has 6 sides, you have 1/6 the probability in the long run of rolling any one of those numbers. Let's read more. So now suppose that a person plays the game a total of 250 times and they picked paper 71 times. We want to create a simulated distribution of sample statistics. We want to use a computer to see what would it look like under a certain set of assumptions. All right, so before we go fill in all this stuff about the one proportion applet, let's deconstruct this problem. All right, so it's kind of hard to figure out, but the first thing that I always say, right, is to see, did the question ask you, or is it looking for an average or a mean? No, it's not. So that automatically means, even though it's hard to sort of figure out what it is at this point, that we're talking about categorical data. So we're talking about pi and p hat. So we want to be looking for ways, because pi is the long run proportion of something and p hat is the proportion of successes out of our sample size of the sample we took. We know we're going to look for stuff that's a proportion. Well, let's see what we have here. So a person picks each outcome randomly. So in the long run, someone is going to get rock, paper, or scissors 1/3 of the time. So that's the general situation. This is actually the population. But the next sentence sort of has a clue. It says, so suppose that a person plays the game 250 times. That's actually our sample. Okay, we're playing 250 rounds of rock, paper, scissors. I'm going to abbreviate. And then it says we picked paper 71 times. 71 times out of what? Remember, we want to create a proportion or a fraction. 71 times out of the 250 times we picked paper. That's our proportion of success. 71 out of 250 in our sample. So let's go back. Our population is, in the long run, rock, paper, scissors games. So like if we played rock, paper, scissors over the long run, all right, all the rounds of rock, paper, scissors. And our parameter then is, because we can come up with a theoretical value. There are 3 outcomes. We know to get any one of them would be a 1 in 3 chance over the long run. So this is the long run probability of getting paper in this case, or any of the options. This is our proportion of getting paper out of 250 games. So always can put our problem into these 4 categories. All right, so when we create a distribution, we want the computer to simulate a distribution for us. The first assumption is the parameter is always true. Well, here's my parameter. We have proportions of success, so we're dealing with pi. Pi equals 1/3 or equals 0.333. What is our sample size? Well, our sample size is the thing that goes with our sample right here. N equals 250. And then we want to repeat it a lot of times. So did it tell us? It didn't really tell us. This problem isn't going to ask us. So what we would do is we would either repeat it 100 times. So we'd have, we'd play 250 games. We'd have it simulate how many times did we get paper out of 250. And we would do that 100 times or 1,000. So the result of that, so when we do that, the computer is going to create a bunch of dots, a distribution, and it's going to, the center of it is going to be near or approximately equal to pi. So that's going to be approximately equal to 0.333. And then what we want to do, the whole goal is we want to compare our sample statistic to whatever the computer generates. So we have a p hat of 71 divided by 250. That's what we're going to compare to whatever the computer simulates up here. So let's see what the question is asking us. It says when we go to the one proportion applet, what value should be entered under probability of heads, or it will turn to probability of success, pi. Well, that's just here. And if you look at the sheet that I gave you that's posted in Lumen, it has step by step. But we want to first assume the parameter is true, pi equals. So we would enter that 0.333. That would go in the applet. What value should be entered under the number of tosses, or that's the sample size? Well, I know here, I just told, right? We figured out the sample size is 250. So then the simulated distribution of sample statistics, this is going to be really the computerized creation of those dots. All right. So it says that distribution will be centered approximately at what value when we click proportion of success. All right, well, we say here the distribution is going to be centered near what we told it to be, which is pi. So it's going to be centered at approximately 0.333. We told it to be. And then lastly, it says the simulated distribution of sample statistics, that's all the dots that the computer created, will be centered approximately at what value when we click number of success. Well, we said that proportion of success is equal to number of successes divided by the sample size. That's the three variables that go into this. So we know, all right, we want to know where it's centered at. Well, we just said that the center is approximately equal to 0.333. So we're going to that's our proportion of success. 0.333 is equal to the number of successes divided by n. Well, what's n? Well, we said n is 250. So we just need to solve for the number of successes. Well, how do I do that? I'm going to multiply both sides by 250. So that reduces out. I'm going to multiply this by 250. All right, that's going to give me the number of successes. I think it's about 82 or 83 if I multiply that out. And then what I'm going to do is I'm going to show you below when I put it in Rossmann Chance. All right, so it's about 83 right here. So if I put it in Rossmann Chance, here's both examples. I'm going to put in pi here, 1/3 is equal to 0.333. I'm going to put my sample size here, n equals 250. I'm going to repeat it a lot of times. I just put in 100. I click summary statistics, I click draw samples, and I tell it to give me the proportion of success. So when I come down here, all right, so we told it to assume 0.333 is true, and that's pretty close. It generated a mean of 0.332. So the center of the data, when we look at proportion of success, is 0.332. If I click instead on number of success, which I did here, same data, all same information as here, everything the same, and all I do is click on number of success, You'll see here that now I have a mean of 82.96. Again, here's my proportion of success is equal to actually 0.332. And if I want to switch to number of success, I'm just going to take 0.332. That's the center of the data here, is equal to number of successes over n. Well, I told it I put n of 250 right here. So if I put that in, I multiply both sides by 250, that's going to reduce out. I'm going to get number of successes is equal to 82.9. That's a little bit off when you do it, but that's what's there, right in the center there.